So, um, the thing here is that she obtained three different values. Yeah, she obtained three different values for the angle of refraction. The smart thing to do is to take an average of those values, and using that average, find the range that find the maximum range from the average that any one of these values could take, right? So you've got x1, x2, and x3. Now the average is often given the symbol x hat, or x bar, right? So x1 equals 28, x2 equals 25, and x3 equals 22. So x bar is going to equal all of these added together divided by how many of them there are. So you should cover this in maths.
But that's not range, isn't that, what one is that? I can't remember which one it is, but when you add and you divide by how many there are.
That's an average.
Okay.
So you should have, or you will cover this in maths. So we've got 28 plus 25 plus 22.
So is mean and average the same thing?
Same thing. So calculate that. What do you get?
I will have a calculator for this paper, right?
So you mean you don't have one?
I do have one. I'm asking if I'd be allowed to have a calculator
Oh
for
yeah,
this.
yeah, yeah. This is a physics paper. You would be allowed to have a calculator for this one.
Okay. I got 25 as the answer.
25 as the exact answer. Okay. So you have
When
20.
I did them all, I got 75, and then 75 divided by 3 gave me 25.
Okay, cool. So all of that equals 25. Now, what you want to be doing is that you want to judge how far away from the mean these values these values are on average, right? So if we compare 22 with 25, how far away is it?
Uh, like 3 degrees away.
Okay. And if we compare 25 with 25, how far away is it?
It's not. It's
Okay.
like 0 degrees, I guess.
And if we compare 25 with 28, how far away is that?
Oh, so 3 degrees.
3 degrees. So generally, the uncertainty is 3 degrees. The average is 25, but we've got two results that are plus minus 3 degrees. 22 is negative 3 degrees from the average, and 28 is positive 3 degrees from the average. That is your uncertainty. That is how uncertain you are in your result. The fact that your whatever measurement you take can vary 3 degrees up or down from the mean. Yeah. So you can say x hat minus x1, and I'm gonna put these bars on the outside, which stands for the absolute value, is 3. X hat minus 25, well, x2, sorry. Again, the absolute value is 0. And then x hat minus x3, again, absolute, is 3 also. So therefore, the plus, the uncertainty is plus minus 3. This is badly written because Jamboard is weird. Anyway, 3 degrees. I would write 3 degrees for that. Okay. Do you have any questions on this?
So if instead of 28 you had 29,
Okay.
what would your answer end up being?
Okay. So that's a good question. So we have 29 plus 25 plus 22 divided by 3 and that gives us 25.3. Now here is where it gets, you need to judge your how accurate you want to quote your data. Here, have you done decimal places and significant figures?
Yeah.
Okay, so here is where you need to decide, okay, do I want to start quoting in decimal places? I would say yeah. So the average is 25.3 decimal place. Sorry, to one decimal place. Okay, to one DP. Now, again, you compare this average to your three values. Yeah. So 29 compared to 25
Oh,
is 3.7. Sorry?
3.7, yeah.
Okay. So you got 3.7. Uh, 25.3 take away 22 is 3.3. And then 25 take away 25, what the absolute values. So 0.3. You are always going to choose your largest, you are always going to choose your largest difference. You should always choose your largest difference. So your uncertainty here is going to be plus minus 3.7. Because as proven by the 29, your value can lie up to 3.7 degrees away from the mean or away from the average. So you would use plus minus 3.7, as that's the range in which any one of these values can occupy. Okay, good question. We've got one more question out of this refraction question. I know it's a long question. You should have done it for homework. It's a long question, isn't it?
Yes, very long.
All right. What property of the light wave changes when it is refracted? Think about your question very, very carefully. In fact, think about why the light would change direction in the first place. The idea of refraction is that light changes direction. Why does the light change direction?
Is it what we said before because of the density?
Okay. So, density is related to the really simple word that you used before I corrected you with density. Density is related to thickness, isn't it? So, if you're running, yeah, if you're running on pavement and then suddenly like there's mud and you start running through mud, mud is thicker than the air. Well, I mean, you're not running through pavement, but you're running on the air on the pavement. So imagine if you started running through mud. What is the difference between the mud and the air that you are running through?
The mud is thicker,
The
so
mud is thicker. Sorry?
so it'd be more difficult.
It'd be more difficult. Why would it be? What's the result of it being more difficult? What is the mud's effect on you?
Your speed is slowing you down.
So we slow down. So when we think of refraction and the fact that light changes direction from one optical medium to another, it's because it has slowed down.
Yeah.
Or if it's gone from glass to air, because air is thinner, it's gonna speed up again. Okay. So what's the correct box to tick in this question?
Velocity.
Very good.